Good day to you, my dear friends. It's time to solve some LeetCode problems. Yay. Oof. As usual, I don't have much time, but still we have to solve LeetCode problems. And we have a huge backlog, by the way, of problems that we already solved during our streams or previously before I started streaming. So, let's go back to problems. On the first page, easy difficulty, maximum acceptance. We already discussed most of them. Our next victim is I don't even remember. It was this. Oh, daily leads and partners. Yeah. So, what is the problem? We have a table with date. It's funny that it's called date ID, but okay. A make name, different car makes, lead ID and partner ID. And we want to count unique leads for every date and make, like this. So we have this date, this make, 2 leads, and so on. By the way, it's ugly. But okay. Whatever they ask. Because our job is to solve, not to ask questions. Let's select, well, date ID, for sure we're gonna need date ID. What else? Make name. Now, let's think, what do we want to have here? For every date, we have lead ID. We can't just count them, you see, because some lead IDs are repeated, like this one, twice. And we can't just choose maximum number, because on some days some IDs are missed, skipped, you know. Like here, look, lead ID is 0. If we want to choose maximum value, we're gonna have 0. So there. Of course we want to count them, but we want to count only unique lead IDs. Then we're gonna have our answer, almost. So we want to count. We did the same thing on the previous MySQL problem. So we count distinct lead ID. And we're gonna call it unique leads. And the same thing we're gonna do for partners. So it's gonna be partner ID and unique partners. From daily sales. Let's check it. Of course it's not gonna work. Oh, it's MySQL server. I don't know why. Jesus. Yeah, I do not know much about MySQL server. I'm What, I used it wrong again? Should be like this. I forget this thing every time. Every time. Without exceptions. Let's see. No, 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 no. I always manage to break something. Ugh. No, it's not about this thing. This thing should be inside the brackets. I believe that. Maybe we need a bigger as. I don't know. What the hell? I have a typo somewhere. Let's do this without. Maybe the reason is that it can't work without group by. Group by date ID. Let's try this. What do you mean? Really? That was the problem? I can't believe that. Come on. This... Yeah. But we have a one line. Of course we want to group by date ID. And not only date ID, because we want to have data for different make names. It's like my first day at this. Why so many mistakes? Yeah, you see, we need to also use make name. Oh boy. No, sometimes SQL doesn't care about all the spaces. Like we can make a ton of spaces here, I guess. And it's gonna be alright. Yeah, here, and here, and probably here, and here. Yeah, and we can even bring it to another line, I guess, something like this. Let's check. Still gonna work, but don't do this. It's gonna break everything. Welcome to the charming world of MySQL, my dear friends. So, this was problem 1693, daily leads and partners. And it's done. Now, as I already told you, recently I discovered this section about arrays, and they have problems related to arrays, and we already discussed duplicate zeros, merge sorted array. Now it's time for remove element, I think, but let's solve it not here because it's very ugly. Remove element. I like this environment better. So it turned out that I already solved this problem back in the day, but let's discuss it. Let me rename. Okay. Whoa, what the hell? Okay, offset, if offset. So what's the problem? I got carried away. As always, we have an array and they give us a number, and we want to remove all instances of this number from the array, and we also want to count all numbers that are not equal to this one, and we want to return this number in the end, number of integers that are not equal to 3 in this case, or 2, and so on. And when we remove elements from the array and we move all the other elements, their order is not important. They can be presented in any order, and they're gonna check only the first k element of this array, so it doesn't even matter what we have in the end. Are they really destroyed? Are they nil? Are they presented at all? It doesn't matter. We won't even look there. So what was my logic here? I have these two elements, k and offset. We can even remove this for now. Let's draw. Aha! So, what do we have there? 0, 1, 2, 2. 0, 1, 2, 2, 3, 0, 4, and 2. And we want to remove 2. So we iterate, right? And we iterate with index. So we start here, of course, and we check if this number is equal to this value, and it's not. If this is the case, we just increment our k. So let's do this. If num equals value, we do something, else we do k this. Right. Then we are here. The same story. It becomes 2. Then we are here. And what do we want to do here? We can just look, for example, at this array. we have 3, we can just look for the next element and replace 3 with 2, right? Well, in this case, yeah, but in our case, the next element is also 2. So we can't just do something like num I equals nums equals nums I plus 1. I mean, it will solve some of the cases, but not all of them, of course. And because of that, I invented another solution. If we have this value, so this is our condition, then we want to increment offset. So here we just increase our offset by 1. And we are here, we moved. Again we have 2, we increase our offset, now it's 2. And now we are here. And it doesn't equal 2, it's 3. So again we are here, and here we want to use our offset, because we want to replace finally this element with a 3. So what do? Well, we replace nums I minus offset with the num, and we can do this every time, because in the beginning our offset is 0, so we're just gonna replace a number with itself, or we can add this check, but it's the same thing actually. We can do something like if offset is more than 0, then we do that. And now we move here, we have 0, we put 0 here, we put 4 here, we put 2 here, no, we don't put 2 here, we have another 2, you know, and we again increment our offset, it becomes 3, and we move here and there is nothing there, right? And you will say that this is awful, we have a 2 in our array, but we only gonna check, as I said, the first k elements. It will be something like this, so it doesn't matter what we have here. This is my solution, I believe it's good. Let's check. Maybe not. It happens. Great. Now let's check the solutions section. We have many strange things here. For example, here we replace everything with nil. I mean, if we have, if this condition is satisfied, we replace the number with nil, and then we iterate and remove all the nils, and we return, and we do this with the bank, so we do not create a new array but replace original one. I don't think it's beautiful because what do we do here actually with the bank? We still, I think, we need to check it and look at the source code, but I think we still create a new array, we just replace original one with it. That's all the difference. So maybe we do not do anything, we don't create any new arrays in our code, but we still do this under the hood, you know? So I'm not sure if this is a good approach to use compact like this. You see, they want us to do this in place and using compact even with a bang. Seems like a cheat here, I don't know. What do you think, my imaginary viewers? And also there is a even funnier solution. This guy deletes value from nums. Then again he uses compact with a bang. But notice he doesn't even return k. Let's also remove k. What gonna happen? Let's return nums. What's gonna happen? No, doesn't work. Why does it work here? It's crazy. It's an interesting solution. Let's check what's going on if we do nums delete. What do we have in nums? I hate this type of problems. They do not let us experiment. It's awful. Let's do something like Ruby online inline. No. Don't know which one. Hello? Oh. Let's have something like this, and let's delete. No, let's call it nums. Now let's nums delete 2, and let's put nums. Oof. Oh, I just print nums. What? Jesus H. Christ. I don't know what's going on. Good. So why does this work? Is this some kind of a bug? Nums compact. What? Where we were? Here we were. Nums compact. Well, yeah, nothing, because why nothing? Oof. Okay, let's use nums compact and puts nums. Interesting. Let's look what compacts return. Compact with a bang, not just any. What? Removes nil elements from the array. Returns nil if no changes were made, otherwise returns the array. Well, this just shouldn't work. I don't know why it works at all. I think it shouldn't. It definitely do not count anything, but it's good. So this is a very strange section, very strange solutions. Although there is a nice two-pointer solution. Let's try this one. Let's try to reconstruct it. So we want to have, let's call it length. It's gonna be num's length, of course, and we want to have index. It's gonna be 0. And while index is less than length, we're gonna do our loop. Again, we check, of course. We check if nums I equals val, we do something else, we do something else. So what do we do in case of else? Well, of course, we increment our index. Makes sense? Probably. Yeah. Let's draw. Again, what do we have? 0, 1, 2, 2, 3, 0, 4, 2. So our I index is here. Our length is here, not even here. No. It's here. So the first thing we do is we have a match. Because if we don't, we just go more and more and more. And here we have a match. 2 equals 2. What do we want to do? We want to check this thing because there is nothing to catch here. We're too far away. So we move L here. We have another 2. Okay, we have another 2. Let's do nums I equals nums length. So what's gonna happen here? Too many things opened. We're gonna take this 2 and we put it here instead our 2. And we check this while condition again. It's true. We check this condition again. Still true because we again have 2. Again have 2 in this place. And then we move L one more time. Now it's 4. We put 4 here. Great. Let's move. Again we have a match. We have 2. Then we move L. Now it's here. And we replace 2 with a 0. So we have 0, 1, 4, 0. Then we move here. We have a 3. And at this point, well, not yet. And we move one more time. Okay, probably. Because at this point, I equals 0, 1, 2, 3, 4. It's interesting. I think we want to do Let's check it. I'm not sure about it. It's gonna work, right? No, of course it's not. Oh, but it should. It doesn't work because we have to return length in the end. That's the only reason. Otherwise it was correct, I think. Yeah, it's all good. So what do we have here? L, it was in the beginning 1, 2, 3, 4, 5, 6, 7, 8. It was 8. And we do 7, 6, 5. So L is 5. What about our I? It was 0, 1, 2, 3, 4, yes. It became 5 in the end at this position. And here we stopped our loop. And what do we have in our array? Something like this. I'm not even sure. Let's check. Yeah, exactly like this. Remember that we have a condition that we may return numbers in that array in any order. So we saved all the numbers. Of course, they are presented in a strange order. It's like backwards, but it works, and it's a fun solution, I think. 2 pointers, you know. So I think this is a clever one. Of course, I wasn't the one who invented it. Oh, nice. Now let's solve something new. Although I'm so tired. Let's close everything else. Where were we? Everything solved here. Maximum depth of an tree. That sounds scary. Okay, we have a tree. Find its maximum depth. Oh yeah, it's not a binary tree, so every node can have any number of children, you see. Why do we have C++ here? Jesus H. Christ, what's going on? That was very strange. All of a sudden, it forgot my language. So many strange things today. First of all, we had a problem with MySQL, that was very strange. Now we have this. So, okay. Okay. We have an array depth. We have a root here. You can have 0 nodes, by the way. So we're gonna do this with compact, because what if it's a nil, huh? And we have a counter. It's 0 or Do we start with 1? Yes, we start with 1. No. We can have 0, of course. Let's add a guard clause for now. Return 0 if no root. Now we can do this. We do not need compact anymore. So while depth is not empty, let's not call it depth, it's a stupid name. Let's call it level. Much better, right? While level is not empty, while level is not empty, we're gonna do a loop. Let's add new level array and level each do. Let's call it node, and we're gonna put in this new level array is it children? Yes, node children if node children is not empty. Now we want to do level equals something like this, and of course by the way, let's start with 0. We're gonna increment our counter here if we have even the first node. So we do not need this guard clause. Compact. We're gonna return counter. Probably I forgot something. Oh, it's an array, right? And we do not have children here. Like this, then no. What do you mean? Do I have a typo somewhere? Wait. We have an array here, right? You want to do something like this. Great. Because we tried to shovel children into this array. So it's not that bad, but okay. Let's check it against everything. Great. It's a very bad result all of a sudden, I don't know why, but it's okay. We create this new array every time. Maybe it's better just to have it here, you know. I'm not sure. Maybe it's better in terms of megabytes. The same. It doesn't matter. Now it's 100%. Do this long enough. Okay, it's good. Can we simplify it somehow? I don't think so. By the way, it's called breadth first search. Can it be done in some other way? Probably. Now let me think about it. So, let's say we have a counter variable, we have our root, and if root, or just let's have another method for now. For now, only for now. Let's call it go deeper. By the way, we do not call methods like that in Ruby. It should be like this. No respect for the language. Go deeper. We're gonna give it a root, believe it or not. So go deeper. Go deeper. Doesn't work. So we go deeper. No, not like this. Not like this. No, no, no. No, go deeper root, fortunately. Like this. Here we want to just return, well, return if no root, you know. But if we don't return, no, return if no root. Or no root children, right? Otherwise we have children, and if we have children we want to increase our counter. No, 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 we can't do this like that, because we are going to increment our counter. For every child, it's going to be ugly. We do not want to count, you know, nodes. Okay, if you want to do it like this, you want to return 0 here. It can be done, but it's very ugly. Like for root children each do child node. Well, let's just call it node. We're gonna have max depth equals 0. And we go deeper node. Depth. Let's go deeper. Let me just counter. I'm gonna send our counter here. No. Yeah, max depth is gonna be equal to new depth if new depth is bigger than max depth. We want to return max depth. It's gonna be counter plus 1. Oh no. Nah. Wait. I don't know. I probably forgot about something. 0. Why is it 0? Oh yeah. Well, that is depth first search. And I think we can do a one-liner out of it, of course. Probably. First of all, let's map. So we have all this new depth. You want to have maximum, I think. And max depth is gonna be equal this. But it can be 0. It's not max depth, it's new depth, right? It's a new depth. And if oof, yeah, it's gonna be ugly. Let's do max depth. If I can't make it beautiful, I hate this. Or maybe it's good. Probably it's good. Right, and we don't need this, we do not need anything. No, 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 it's now. Why is it now? One thing it can't be is now. Oh, I know why. No, I don't know why. It's very interesting. No. Not no root children, but if root children empty, beta. Yeah, but we want to add one here, of course. No, 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 not one. Let me think. A second. Yeah. That's too funny. How can this be? When we do this like this, it's 2. When we do this like this, it's 4. So now test case failed. Right? No, no, the same. Nice. So we can say that this is a new depth, right? It's gonna be too big. Yeah, even bigger. Okay, we want to have this array. And again, we want to do max. Maybe this is a problem. I want to have a one-liner. Let me look at this one more time. It's a miracle it worked in the first place. Let's try it. Right. So we already discussed that this should be like this. That was the problem. We have a very stupid return condition. That's what I discovered. If we do not have children, we want to return counter, I think. Counter plus 1, no. Well, yes, counter plus 1, because we still have children. We still have this root, this node, we still have. It's so stupid. It's different cases. We want to return 0 if there is no root. And we want to return not even 0, counter. And we want to return counter plus 1 in this situation. Yeah, but now we have even more lines. Do we need this check? We return counter plus 1 here, right? But we can have, let's check it. Maybe we do not need this at all. This check, right? Well, now again I want my previous logic. like root children map go deeper. What? I said go deeper. I'm so tired. Underscore 1. With max here. What is this? Oops. And it's gonna give us nil. Yeah, of course. Max or max depth. Gonna do compact. Max. Great. Then we do not need max depth variable anymore, just counter plus 1. Let's submit. Now we're gonna do this. We're gonna check root. If root, we're gonna do this. If not, we're gonna do counter. Counter. We do not need this anymore. Great. God damn it. We're gonna call it max depth. Please work. Please work. Yeah. The gods of random. Love us today. So this is a one-liner using depth first search. So we solved it both ways. Yeah, ways. Oh, it nearly killed me. It wasn't hard, you know. I always create all these additional obstacles, like let's do a one-liner, or let's try to do this some other way. But it's good, I'm happy. And what I wanted to solve also is this problem. Remember from the lead room, we had the first problem, minimum rectangle area, that we tried to solve for 5 days. Now we have this problem, it's the second one from the same room. And luckily for us, lead coach was in our chat, and he said that our nums here, our indexes, don't have to be like consecutive. They do not have to go one after another. So what do we have here? We have an array nums, and we want to take one number from here and one other number from here, and to find the difference and an absolute value of this difference. And we want to take minimum difference possible and maximum difference possible, and we want to add them together. It sounds very complicated in my description, but it's actually not. And I thought they have to go like one after another. You have to compare 1 and 4, 4 and 7, 7 and 8, 8 and 5. But actually we want to compare 1 with everything, 7 with everything. But notice that we have a module, not module, how do we call it in English? Absolute value, right? So the difference between like this element, which is the first, and this element, which is the last, it's exactly the same as if we change the order, right? Exactly the same. What does it mean? It means that we do not have to carry about, not to carry, to care about a position at all. No position doesn't matter. What we have to think about is that minimum difference is just the difference between smallest number and the next, like the second smallest. And maximum difference is the difference between biggest, of course, and smallest. Right? So if we say sort this array, it becomes, let me write it, 1, 4, 7, 8, and 5. Let's sort them. So it's gonna be 1, 4, 5, 7, and 8. So if we sort it and we take like the first two elements, the difference between them, 4 minus 1, it's going to be our minimum difference. And our maximum difference is the difference between last element and the first element. It's our max. Of course, it's a model, but it doesn't matter for us because they are sorted, and this element is always bigger than that one, and so on. Now, the question here is that we are allowed to make two changes, to change two numbers, any of the numbers, so that this sum of min plus max, it must be the lowest possible. So what is the lowest possible sum of these differences that we can achieve by making only two actions, by changing only two numbers? That is the question. Let's remove everything because it's bullshit. Let's sort them. Well, we can always make this one equal to 0. We just have to change this one to 5 or this one to 4, you know? So we can always do that. So let's concentrate as a first action on the difference between minimum and maximum, between last element and first element. So let's call it, our max number is nums last, not nums, sorted last. Our minimum number is sorted first. So max difference is max minus min. Min difference, we need another variable here. For now, let's call it second min. Sorted 1. Second min minus min. Now let's think how can we make max diff minus, not minus, plus min diff smallest. As we already say, we can turn this to 0 as a second action anytime. This one is worse because sometimes we want to say turn 1 into 8. Then the smallest difference, the max difference going to be the difference between this one and this one. No. Still gonna be this one, the last element, and the second element. But in some problems, it's definitely better to make biggest, say, equal 1, equal smallest, and we have to choose, and I'm not sure how to make this choice, you know. So we have this max difference, but what we gonna have as max difference if we increase the first element and this becomes the smallest? So new, let's call it new max difference, is gonna be max minus second min, right? Right, another way to go. Let's call it first way. And this is going to be second way. If we're gonna turn this into 1, then we're gonna have as a minimum difference, as a maximum difference. I'm sorry, I'm so distracted today, I'm all over the place. It's gonna be 7 minus 1, so it's gonna be let's introduce another variable, second max is gonna be sorted -2. So this is gonna be second max minus min. So we can go in one of these directions. If this is smaller than this one, or equal, let's say, then there is one way or another way. Yeah. So if we want in this direction, then our new max is gonna be it's gonna stay the same, but this one is going to change. It's going to become second min, you know, and second min is about to become sorted. It was 1, now it's gonna be 2 probably, but it actually depends on the real numbers. Do we want to sort it again? Nah. Are they all different? We do not know that, right? They are all different in our examples. Yeah. No, they all can all be similar. Well, okay, if this is the case, then we want to change sorted. I do not want to sort again. This is killing me. It's okay, let's not sort. Hell with it. This is good. So this is our new values. And in this case, our min stays the same. Second min stays the same, of course, but our max is gonna be equal now to second max. Second max is gonna be even smaller. Okay. But now we want to decide if we want to make our minimum difference equal to 0. So we want to compare now. If second min minus min is bigger then max. Sounds unlikely, but I'm telling you this is possible or not. No. Yeah, we want to check this. No. Oh, so full. So this is the case. So what do you want to do? Then we want mean to be equal to second mean. So they're going to be 0. In this case, say more or equal. And in this case, make max equal to second max. Again. This is crazy. And in the very end we want second mean minus mean plus max minus mean. At least sometimes it's green. It's 3. It's exactly our case, right? Yeah. 1, 4, 7, 8, and 5. And let's sort them. Again, 1, 4, 5, 7, 8. So, by our logic, first of all, this one is gonna be 3, like mean difference 3, max difference 7. And first way, if we want to make this bigger and make it equal to 8, then our new max is going to be 8 minus 4. If instead of that, where is it? This one. What was it? 1? If instead of that we turn 8 into 1, then max d, it's like the first max d, it's the second max d. It's gonna be equal 7 minus 1, 6. So we go in this direction. No, this direction. And now a new minimum is going to be 4. Well, makes sense because now we have 8, 4, 5, 7, 8. So this is our new minimum. This is new min. This is like second min. I can't write with mouse. Second min. Well, this is max, this is second max. No, that. Now we want to check second min minus min. 1. And max minus min is 4. And we went that route. Which is strange. Yeah, this is our problem here. Oh, I'm so wrong. In this second case, I'm very wrong. You see what is the funny thing here? I don't even need the second move. No, I want it. Let me look at my picture here. Well, yes, now again we want to change it into a 0, not 0.8, or maybe we want to change this into a 4. That's what we want to check. So we're gonna do the same thing again. No, more or less. Yeah, we're gonna do this again, I'm afraid. Yeah. Now what is the problem? I made an assumption that this is the smallest difference, when this is just not true. This is the smallest difference in our example. So our goal here, but no matter what, we did the right thing here. Yes, and I think we want to do this again. I really do. So now for sure we have a 0 as the difference between two closest. So the only thing we want to do is to count like max, minus, min, I think. Ugh. Well, this is a case where we do not want to make biggest number smaller, we want to make smaller number bigger, like this two. Then we have a very small difference. I do not know why this didn't work. I mean, but I checked this case. Here we check this. Maybe we have a stupid condition here. It's so close, it's like I almost see it. I mean, in this case, okay, let's use test case. 31, 25, 31, 25, 72, 79, 72, 79, and 74. And 65. Now let's sort them. 35, 31, 65, 72, 74, 79. So here, if we basically we want to take this and turn it into 79, and then turn this and turn it also to 79. Then our difference is gonna be difference between this one and this one, and it's 14, just as they want. So it's easy. And we have a condition, this not too bright condition. Max minus second min, 79 minus 31. That's what we check. It's gonna be equal to 48. Second max minus min, 74 minus 25. Mm-hmm. 20, 54, it's 49. So this one is smaller, so we go into this direction. Min is now, this one is now considered to be minimum. This one is second minimum. Okay. This is still max. Now we're here again, max minus second minimum. It's 79 minus 65. Well, that's our 14. And we compare it to second max minus min. Where is it? Second max, 74 minus 31. Oh, I know. Of course. Now it's gonna be 3, and this now is gonna be ay ay ay. We need to have it as a variable. So second min index. Like this we wanted. The same for this one. Second max index is gonna be equal -2. And it becomes even smaller, and it becomes even smaller, like this. Oh, I broke something. Like this. Yeah. Come on. Oh, not like this. Of course. Whoa. It's almost painful to think. Oh boy. I guess it's a lot easier, actually. Now it's gonna be 14. No, it's still 43. Why is that? So we went here, 70, what is it, 43. This is smaller again. We again go here. Mean is equal to second mean. Oh, this is my problem. This is my problem. Oh, I have many problems here, by the way. It's like a typo here, and it didn't say anything, so we didn't even get here. Let's try. It should break. Ay. So many typos, and still it's working. Of course, it's like we introduced a new variable here. Now it's all green. You see, there was a typo, and it was a very dangerous one. Still, of course, there should be a test case that is going to kill us. Right, but we are almost done. So, we can't just pass it. Well, let's use this test case. 21, 13. Oh no, let's make it a little smaller. 21, 13. 2172. Oh yeah. Oh yeah. 3552. 3552. And finally 74. Let's sort it. 13, 21, 21, 35, 52, 72, 74. So we look at this one. I see the problem here from a mile away. This is a problem, but okay. So looks better that we want to turn 13 into 74. Then we look at this and we turn 21 also into 74, and the biggest difference is 74. Minus 21, and it's gonna give us 50 something. Well, that's bad. Yeah, but actually what we really want here is probably turn 74 into 52. Well, at 72 at first. Oh no, in 13. 213. It's 13. This one is also 13. Now 52 minus 13 is the difference. It's gonna be 39. Yeah. Problem is, of course, that we have 21 here. What if as a first move we turn this one into 74, as a second move we turn this one into 21. Now the difference is huge. No, it's not gonna work. So almost immediately we need to understand that this way is gonna give us a worse result. It's like we want to go in every possible direction and just choose the smallest result in the end. So how many different approaches can we have? We can change these two, we can change this one, we can change these two. No, we can change middle ones, like something like this, but it doesn't make any sense. Okay, so the question is, let me remove all this for now. It's like we want to compare sorted what can be our biggest? Sorted -1 minus minus sorted 2. This is our first variant, and the second variant is it's sorted minus 3 minus sorted 0. We want to know which one is smaller, I guess. Or maybe there are even more variations. Let's see. Better, huh? Okay. We hit that one. Use it. What was its number, by the way? Let's check. 57. Ay, ay, ay. So we have 58, 42, 8, 75, and 28. Let's sort. 8, 28, 42, 58, 75. So let's check. We want to turn this one into 75. And then we want to turn this one into 75. So the difference now is 75 minus 42, which is 33. And the answer is, the answer is 30, because yeah, probably this is another variant, like we turn this one into, say, 58, huh? And this one also into 58. Then the difference is 30 between 28 and 58. Wow, 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 wow. Oh, this is awful. No, I am able to solve this only because of the test cases, and it's like, it's very bad. So this is minus 2, minus 1, I think. Yeah, well, that's wrong. We do not need any of that. Probably we don't even need this. Okay, we solved it. Well, yes, you know. Well, yes, you know. It's a relationship between just three numbers. Smallest one and two like biggest. No, I paid too much attention to second number and it doesn't matter at all. Well, it does matter. A little. Alright. Do we even need this? I guess so. What if there were more test cases? Maybe I can add a test case that can break everything. Is it possible? Oh. Let's not talk about one-liners here. I do not want to sort it every time. It's not a solution, it's bullshit. It doesn't have a strong foundation, you know? Doesn't have a good theory. So it's obvious that if we have these numbers, we can either change the first one and the last one, or the first one and the second one, or the last two. Everything else just doesn't make much sense. What is the time? Is LeetCode still asleep? It would be nice to have him here. Well, even without him, you know, tomorrow or some other day I'm gonna check solutions section and I will understand why does it work like that. And maybe I can come up with a new test case, because I think I can break this. It looks like that. Okay, enough for now. We achieved a lot today, a lot more than I hoped for. I guess I'll see you tomorrow. Tomorrow there will be a contest. So, but what's even more interesting that, you know, we already solved all the problems from our previous lead room, so we can create a new one. Maybe tomorrow also. Although it would be hard to do lead room and contest. Oof, we'll see. We'll see. So I'll see you tomorrow. Thank you very much, my imaginary viewers. I appreciate each and every one of you. And especially I appreciate people that subscribe, follow when I am offline. Thank you very much. I'm very happy to discover your subscriptions later. Thank you very much. Now it's time for me to go. Oof, I'm so tired. Goodbye, my dear friends.